My name is Jeff Dembiec. I represent a company called ChemFresh. We produce a product called Oxcide, which is a very unique formulation of hypochlorous in water. You'll notice that over on the left-hand side, the safety level of this product, there is no flammability, no interaction with other products, and from a health standpoint, it's very safe. If you were to get this product on your hands and on your face, you simply wash it off. There's very, very little to worry about when using this product. For people that may have irrigation systems that could potentially be tied to an office or something like that, this product is actually NSF approved for drinking water applications, and it is also OMRI listed for organic applications. And for probably doesn't apply to the agricultural market, it is kosher approved, which is something that is important for the food industry, which is also one of the other applications for Oxcide. In the horticulture industry, we use Oxcide for treating greenhouses, hydroponic applications, and any growing or irrigation application that might exist. The product is non-phytotoxic, so it's very friendly to the plants. We found that it increases propagation success in the plants. It improves nutrient uptake in that it allows the nutrients to mix better with water. It's very compatible with most fertilizers that are out there, particularly organic fertilizers similar to Daniels and so forth. It helps the solubility in the water quite a bit. We find improved shoot mass with using Oxcide in the water. If you have cooling pads in your facility, the Oxcide breaks down the scale that's on the cooling pads and helps remove that so that you get better efficiency from your cooling pads, as well as helps clean them up and makes them last longer. Overall, we find that the overall greenhouse health is much better because we clean up the scale, the harbor sites for microbes and so forth. Because Oxcide is used to remove scale components from your pipeline systems, there's no more need to use acid for cleanout. When you use acid, you generally have to shut everything down, get all your plants out, and so forth to be able to flush the system. When you use Oxcide, you can do that in your normal irrigation water and clean the system out as you go. It's very easy and safe to use. You use a normal injection system that you might already have in your greenhouse and just apply it to the water as you would use it. And Oxcide is very economical use. We use very low concentrations, generally nothing more than about 1 to 8,000. Quite often we're as high as 1 to 10,000, 1 to 12,000, depending on the cleanliness of the system. And as I mentioned earlier, it enhances the solubility of many fertilizers. What we will find some growers do is when they make a batch tank of fertilizer, they will add a little bit of Oxcide to the water fertilizer solution, stir it up, and that makes the fertilizers go in the solution a little bit better, particularly if they're solid fertilizers. Again, this is a non-toxic product, so you can use it anywhere you want. You're not going to do any harm to your plants. Even at concentrations of 1 to 1,000, we found that it does not harm the plants at all. Again, no phytotoxicity. Apply it to your plants as much as you want with your irrigation water. It's a non-hazardous product, so there are no special shipping requirements in this, no special gowns or masks or gloves or anything required to be able to handle a product. One of the nice things about it is it's low sodium, so you can use this and not have to worry about salt building up in your water and your plants and your soil, things like that, and it's at a neutral pH, so it's not going to have any effect on anything that you're doing to the water as far as your pH adjustments and so forth. And the low ionic strength is a real benefit, again, indicating there are very low salts in the water. So again, we remove the scale. You have no scale, no hard water deposits. That leaves your irrigation systems open and free to be able to do what they're supposed to with your plants. You see here, in particular, we're attacking the calcium carbonates and magnesium carbonates that are in the water. And when the hypochlorous, which is the Oxcide product, attacks these, it breaks it down so that you've got calcium or magnesium, carbon dioxide, water, and a little bit of hypochlorous left in the water. The more we put in, there will be a little residual of hypochlorous, but generally we are not targeting to have very much left in the water. It's not intended to be a sanitizer. It's more to treat the hardness and scale components. We don't have high dissolved solids in there, so if you're treating your water, we aren't adding to deposits like you would if you add chlorine and so forth, because chlorine is going to add more salts to your water, and they really have no descaling benefits. Here you see a typical system demand that has basically structure demand is what we refer to as the scale components that are built onto the surface of your pipelines and emitters, things like that. Then you have your system demand, which is your biofilm, and then eventually you have some residual in the water. And ideally, we want to have just a little bit of residual in the water so that over time we erode this down to the point that we remove the structural demand, the system demand, and leave a little residual in the water to make sure the system stays clean. Now, one of the important things here is that if you were to use a sanitizer in your water to kill bacteria that may be in your pond water or wherever your water source is, once we get the scale that supports the biofilm removed from the system, your sanitizers work much better because they're not spending time going after the system demand and trying to maintain a residual in the water. So once oxide cleans your system out, your sanitizers, similar, such as chlorine dioxide, can kill the microbes that might be in your water much more easily. We find, as you see here, much more healthy plants when we use the oxide in the water because we are getting rid of the demand in the system. We're getting rid of the supporting structure for the microbes, such as you may have algae or places where even microbes like fungus gnats and things like that hide. Once we remove that from the system, we see much healthier plants, healthier root mass. The general environment just improves quite a bit. And you see some of the plant structure on the left with the root masses that we see improve. And in hydroponics, growing the plants helps quite a bit. In this case, you see a typical application where we've put oxide in a greenhouse. Initially, you see on the left-hand side where we started treatment, there's algae growing on the floor. There was scale on the concrete that was holding the algae and able to grow. You even see it on the wood surfaces. Over a period of time, we've cleaned out the pipeline systems. We've cleaned out the floor systems and the growing media surfaces and the ground surfaces by regular application of water that's treated with oxide. The oxide is not a product that you use intermittently. You use it on a continuous basis in order to get the best results from it. So if you're used to a system where you're putting in acid periodically to be able to clean out your system, once you get oxide in there, you use it on a continuous basis. You never really turn it off. You just continue your treatment. You end up with very similar results to what we see on the right here. Quite often in greenhouses, you'll see emitters plugging, whether it's a propagation house or drip irrigation, a variety of things, and you'll see that you'll get a little bit of scale buildup. Eventually, you get the algae buildup, which is attaching to the scale. We remove the scale from the system. We remove the attachment point for things like algae and so forth, and you don't see the nice green beards growing out of your injection system. We keep them clear so that we keep the injection lines clear, and you get continuous watering to your plants when you expect it. This is a little difficult to see, but you can see untreated versus treated water with emitters. The emitter on the right is opened up a bit more, so you get a little better flow. This would be the type of system that goes maybe in a pots for watering larger plants, but we see the same thing on fogging nozzles and a variety of other systems, whether it's drip or overhead, the same results. We get the scale cleaned out of the system, we get the water system opened up so that we get the water flow the way you need it. This is a pretty extreme look at what you can see in calcium and magnesium buildup in water systems. The systems on the left are very, very clogged up, but you can see in all of these applications where the biofilm is basically buried inside the scale, and you get layering. The scale builds up over the top of biofilm, and if you were to run a sanitizer through a system that has scale buildup, you will kill the surface microbes, but eventually the microbes will migrate back out of the scale, re-inoculate your system, start growing on top. If you look at the far right, that's an application where we've cleaned out the scale from the system. It's getting down to the point where the pipeline is cleaned out. You've reduced your harbor sites, and now your system can flow better. When you're using your sanitizer through your system, now it can get at the microbes. There's less chance for them to migrate back into your system. Your pipelines don't become the home for your microbes. Scale and biofilm go hand in hand. Once you've built up scale in your system, the biofilm starts to find a home to live, and it continues to propagate through the system. Once we remove the scale from the system, biofilm is disappearing, and we get a much cleaner system. So we get better water system flow, better cleaner systems, and a healthier system which translates into the greenhouse. Once we clean out the pipeline systems, we clean out your surfaces and so forth where the water is going. Again, another system where you see where we've removed scale that apparently had iron in it. And depending on the amount of buildup that is in your system, we've seen results inside of 30 days. If you have a heavy buildup of the system, it may take a little bit longer. But again, you see the biofilm goes away with the scale. Greenhouse evaporative cooling pads are a notorious place for building up scale because you're removing the water and leaving the minerals behind. With the proper application in greenhouse evaporator systems, as well as we do it in poultry operations and a variety of other places that have these cooling cells, when we use this along with your regular water treatment, we're able to clean up the cooling pads. We get better life, better airflow, and better cooling in your greenhouses, reducing power consumption because you may not have to cycle them as often or as long. So you can see on the left the system that's pretty well bound up with scale, and on the right, after a period of 30 days, in this case, we were able to clean out the system. It's a little different application we have to do with the cooling pads because we need to, in some cases, have a sanitizer in there to be able to treat the biofilm that may be built up on there. And then we also have to worry about the electric conductivity concentration in the water with the scale. Once we dissolve that into the water, we need to be able to flush that out. So there is some makeup water required when we do this. But once we get the systems clean, they generally stay very clean. Again, if you've got a tank that you're feeding the water to your evaporator pads or some other place, by using the Oxcide, we keep the system clean, less support for biofilm, and you keep your system overall much cleaner. Hydroponic applications, again, very good place for it because we don't build up the scale in the systems. It keeps the recirculating water systems cleaner so that the other treatments can perform much better. Typical water distribution system, again, we're dealing with the biofilm. Recontamination, as long as we can keep oxide in the system on a continuous basis, if you're recirculating water, you will prevent the buildup. This is an application or an example of a system where we've applied oxide in a test application where over a period of time you could see that oxide treatment allowed the ORP of the water to build up, and thus when you get a high enough ORP in the water, again, you're going to kill your microbes. Depending on the microbe you're after, generally we can get it, raise the ORP of the water such that you need less of a sanitizer to go in there to bring your ORP levels to be able to kill your microbes. This was an application where we looked at over time what did we see as an increase in ORP, and by applying the oxide in the water, the ORP went up as it cleared out the scale and the biofilm from the system. This was done in a research application and would take longer generally in a pipeline system. This again was some of the plate results that came from the application, that over time you can see the fungal growth dropped off, and with longer period of times we see that pretty much disappear, again because we're removing the home for the microbes to live in. We use simple flow-based injection systems. This is one example of a proportional flow system. You want to have a system that will meter the oxide in at a ratio that is proportional to your water flow. So if you have zero flow, you stop feeding it in. If you have higher flow, you feed more to make sure you make up for it. This is a typical system. H.E. Anderson, other people have systems that will work. Generally, we want to be in an application range of 1 to 8,000, sometimes 1 to 5,000 to start with, but generally 1 to 8,000, 1 to 10,000 is our application range. And to summarize, oxide is a very unique formulation of hypochlorous. It's the only thing in the water, in very pure water, removes the scale and the biofilm. It is a neutral pH, so it doesn't affect what you're doing to treat your water. It's non-toxic, non-hazardous, very low total dissolved solids. It's intended to remove scale from biofilms, scale and biofilm from systems. It is not intended to be a very strong biocide. It changes the chemical interaction of your water with your hardness materials and changes the morphology of it so that we can get it flowing through the system. And when it's mixed in water, even at a millivolt level of 650, we have it's an odorless case where you're not going to know what's in your water. You will be able to measure that it's in there, but it's something that it's not going to be an odor issue in your greenhouses like some other things might be. This is a typical shipping label. Again, you can see there's no hazards. It's listed with the NSF, kosher, and we talked earlier about OMRI applications if you have organic applications. So that's Oxcide. Give us a call if you need anything. Thank you.